Hi, everyone. So we're going to keep going with our examples. So this one talks about using a truth table to verify a logical statement. So this, you can notice, is the one of the Morgan's laws we just wrote up here. So this is not P and Q, is logically equivalent. Whoops, I forgot. The logically equivalent symbol isn't the normal equal sign. It's this 3 bars equal sign. So that means logically equivalent to instead of equal to. So we're just going to verify this using a truth table. So you can use a truth table to verify statements like so. So we just want to essentially write the truth tables for each of these statements and verify that they match. That's the easiest way to use a truth table to verify the logical equivalence of two things. So remember, all of our truth tables always start out the exact same way. So we have a P column and a Q column, and they always start out the exact same. P is true, 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 false, false, and Q is true, false, true, false. Just to keep things in line, I'm going to draw these lines between them, just so everything is all aligned in the same row, because it can get kind of messy depending on how good you are at writing things in a straight line. Okay, so the first thing we want to do is to write this not P and Q. So in order to negate P and Q, first we have to have P and Q. And then we can do the negation of it. So not P and Q. Okay, so that's the first one. So now for the second one, we are going to look at not P or not Q. So in order to combine those using or, we need to have a not P, not Q, and connect them using an or. So not P or not Q. Let me just extend these lines all the way. So I really like to set up my truth tables fully first. That way, once I get to this step, all I have to do is just fill everything in and it goes pretty quickly. So yeah, I like to have them completely set up before I do anything, but you definitely don't have to do it that way. It just makes more sense to me to have it all done at once. Okay, so this is going to be the setup. Okay, so we combine P and Q using the connective and. So remember that and is only true if both are true. So I say this a lot. It's also stated at the top of page 25 that it's true if and only if both P and Q are true. So that's just kind of what I have in my head to help me keep it straight. So and is only true if both are true. So in this first row, they're both true. And all the rest of them in every other row, one of them is false. So this is false all the way down. Okay, and so then we have not P and Q. So remember, to negate things, we just change every true to false and every false to true. So true goes to false, and all of these falses are going to go to trues. Okay, so now we have not P. So this is where I said in the last video that it may be helpful to use your pen or pencil to cover up the rows that we don't need to look at. I'm not going to do that on here just because I can't put a pen or pencil on the tablet I'm writing on and cover it up, but I'll draw a little arrow down here to make sure that when we're looking at not P, we need to look back at P and negate it. So P has true, true, false, false. So we negate that to get false, false, true, true. And then we have not Q. So now, in order to get not Q, we just need to look back at the Q column And so Q was true, false, true, false. So not Q is going to be false, true, false, true. And now we're going to combine not P and not Q using OR. So we're looking at these two columns, not P and not Q. We're combining them using OR. So remember that OR is only false if both are false. Okay, it's another one of the things that I'm going to say a lot just because it's how I remember it the best. That OR is only false if both are false. If I tell you this or this, I'm only lying to you if they're both false. Okay, so in this first row, they are both false. The next row, we have a false and a true, so that's true. A true and a false is true, and a true and a true, they're definitely telling you the truth. And so that's how we look at it. So now we are trying to prove the logical equivalence of not P and Q, this row, and not P or not Q, this row. And you can see that these things are logically equivalent just by looking that this false, true, true, true is exactly the same as this false, true, true, true. So that's how you can use a truth table to show if these things are logically equivalent. You just make the truth table for each of them and see that they're exactly the same in every single row. So that's all for that one. So now these are all the examples we're going to do over not, and or. So these are pretty straightforward. You just kind of have to think that not obviously makes things opposite, and P and Q, just remember when is someone lying to you, and it'll all be pretty straightforward. So now we're going to move to something that is, in my opinion, a little more difficult, and it's this conditional. So this conditional statement is this if-then statement. So it's really similar to your hypotheses in, right, your science classes, that if I do this, then this will happen. So that's your prediction, your hypothesis in your science class. And we're going to write all of these statements in that if-then form. Okay, so remember that if-then form is if P, then Q. So I'm just going to write that down for you. If P, then Q. So in science class, it's if I do this in my experiment, then I predict this will be the outcome. Okay, so we're going to look at all of these statements and write them in if-then form. So the first one is all squares are rectangles. So we're talking about, what are we talking about? First of all, well, we're talking about two things. We're talking about squares, and we're talking about rectangles. So let's make those our P and our Q. So we know that all squares are rectangles. So let's put that in this if-then form. So if it is a square, or if the figure is a square, then what? What is this statement telling us? So then, well, we know that all squares are rectangles. So if it's a square, then it is a rectangle. And so this is an if-then form. So these two statements, even though they look really different, they say the exact same thing, that all squares are rectangles is the exact same thing as if it's a square, then it's a rectangle. Okay, let's move. Well, this is the same for, you can replace squares and rectangles with anything, right? If all chickens are birds, all chocolate is sweet, all flowers smell, anything like that. So everything, all this or this, can always be written in this conditional form in this way. If it is this, then it is this, because all squares are rectangles. So if it's a square, then it's a rectangle. Okay, so this next one also deals with shapes, and it's really similar, right? All is really similar to no, because all or nothing, right? They are kind of opposites of each other, so they're going to work in similar ways. So no square is a quadrilateral. So what are the two things we're talking about? So we're talking about, triangles and quadrilaterals. Sorry, I think I misspoke a second ago. So we're talking about squares and quadrilaterals. Sorry, triangles and quadrilaterals. My apologies. Triangles and quadrilaterals. Okay, so let's start off the same way. We know that if it is a triangle, or if our figure is a triangle, then what? Well, we know that no triangle, oh, my apologies, sorry about that. One second. Okay, let me fix this one above. Okay, so we're talking about triangles and quadrilaterals. So we know that if it is a triangle, then what? So we know that no triangle is a quadrilateral. So if it's a triangle, we know that it can't be a quadrilateral. So it is not a quadrilateral, right? Because no triangle is a quadrilateral. So this one was really similar to the one above it. Okay, so C, freeze or I'll shoot. So this one is a little bit different. It's not all and it's not no, but it has this or in it. So it has this implied if then, and we kind of have to figure out what's happening. So first, let's identify the two things that we're talking about. So the two really clauses in this statement are freeze and I'll shoot. So if we expand this, so what happens if you don't freeze, right? So if you don't freeze, that means that they'll shoot. But if you do freeze, then they won't shoot, right? There's this implied decision here of if you freeze, you're fine. But if you don't freeze, then they'll shoot. So we can write this as if you don't freeze, then I'll shoot. So this or gets transformed into this if then with this negation in it, meaning if this thing doesn't happen, then this other thing has to happen. So if you don't freeze, then I'll shoot. Okay, D. So this one, similar to the one above it. So the two things we're talking about are fix my ceiling and paying rent. So really similar. If you fix my ceiling, we're fine, right? But if you don't fix my ceiling, then I won't pay my rent. So this one's really similar. So if you don't fix my ceiling, then I won't pay rent. Right, so this one is really similar to the one above it. Okay, so this was taking statements and writing it in this conditional if-then form. And so this is a really nice skill to have just when, I mean, even evaluating what people say as this logical thing, how it works. Okay, so that's the end of the second page, and that means that is all for this video.